Hey everyone, and welcome back to Tech Pulse. Today we're going to be diving deep on something super important in the world of JavaScript, testing. And specifically, we're going to be looking at a tool called Jest. It's like having a detective for your code, making sure everything works exactly as it should.
Yeah, that's a great way to think about it. You see, when we build things with code, it's really easy to make mistakes, especially as our projects get larger and more complex. Testing helps us catch those mistakes early on, saving us a ton of time and headaches down the road.
Right, like think about all those times you've been hunting for a bug in your code and you just can't find it. And it's like hours later, and it's just one little thing. So frustrating.
Absolutely. It can be one of the most frustrating parts of programming.
Yeah.
But with testing, it's like having the safety net. It gives you that confidence to know that your code is working as expected.
So we've got some awesome resources lined up to guide us on this deep dive. We've got some great YouTube channels like Web Dev Simplified, freecodecamp.org, and Lathe Academy. Plus, we'll be pulling from Jest's own website, of course. You can find links to all of those down in the episode description. So let's start with the basics. Why is testing so important?
Well, imagine you're building a simple calculator app, right? You've written the code to add two numbers together. Seems pretty straightforward. But what happens if you accidentally make a tiny change later on and introduce a bug? Like maybe you swap a plus sign for a minus sign without realizing it.
Oh, I've totally done that.
Exactly. And without tests, you might not even realize something's broken until like your app is out in the wild and users are starting to get the wrong answers.
Oh, yeah. That would be bad.
That's where tests come in. They're like these little alarms that go off when something isn't working the way it's supposed to.
So it's like having a safety net for your code,
Yeah.
catching those errors before they cause real problems.
Precisely. And as your projects grow, the safety net becomes even more crucial. Imagine you're working on a website with thousands of pages, and you need to make a change to a core piece of code. Tests can automatically check if that change has broken anything on any of those pages, saving you hours of manually clicking through everything.
Wow, yeah, that would be a lifesaver.
Yeah.
I mean, even just like thinking about making a website and then having to go back and check every single page, that sounds like a nightmare.
Yeah, it can be a real pain, especially when you're working on larger projects. I remember one time I was working on this website redesign, and we had thousands of pages to update. And I thought, oh man, this is going to take forever to check everything manually.
Yeah.
But luckily, we had a good suite of tests in place, so we were able to make the changes, run the tests, and within minutes, we knew that everything was still working as expected.
Okay, that makes testing sound way less intimidating.
Yeah.
So how does Jest fit into all of this?
Well, Jest is a JavaScript testing framework.
Hmm.
That's become super popular because it's designed to be both easy to use and incredibly powerful.
So even if you're new to testing, Jest is a good place to start.
Absolutely. One of the things that makes Jest so beginner-friendly is that it works right out of the box, meaning you don't need to spend a lot of time on complicated setup. It also comes with these really handy tools called matchers, which let you make very specific checks about your code.
Matchers. Can you give me an example of what those are and how they work?
Sure. Let's go back to our calculator example. Say you want to test that your addition function is working correctly. You could use Jest to be matcher to check if the result of adding 1 and 2 is indeed equal to 3.
Oh,
It's
got
like you're giving Jest a simple equation to solve and making sure it gets the right answer.
Gotcha. And are there other types of matchers?
Yeah, there are a whole bunch of different matchers for all sorts of different scenarios. For example, for more complex data types like objects or arrays, you would use the to-equal matcher. This checks that the entire structure and all the values within those objects or arrays are identical.
So it's not just checking if it's the same number or something, it's checking if the whole structure is the same.
Exactly. It's like comparing two blueprints to make sure they match perfectly.
Okay, so you're basically setting up these little challenges for Jest. And it uses its matchers to make sure your code passes each test.
Yeah, that's a great way to think about it.
Cool. So Jest can handle those like basic checks.
Yeah.
But what about real-world scenarios where your code needs to interact with things that take time, like fetching data from a server?
Right. That's a great question. And the good news is that Jest is built to handle both synchronous code, which runs in a predictable step-by-step way, and asynchronous code, which can involve waiting for things to happen.
Okay, before we go any further, can you quickly explain the difference between those two types of code? I think a lot of people, myself included, sometimes get them confused.
Sure, think of it like this. Synchronous code is like ordering a coffee and getting it immediately. Asynchronous code is more like ordering something online. You have to wait for it to be delivered.
Okay, I can totally relate to that. So how does Jest handle testing code that's waiting for something to happen, like data from a server?
That's where a powerful technique called mocking comes in. Imagine you have a function that fetches information from an API, which is basically a way for different applications to talk to each other. Jest can simulate that entire process without actually needing to connect to a live API.
So instead of waiting for a real server to respond, Jest creates kind of a stand-in server that gives you back a predictable response.
Exactly. It's like having a stunt double for your API, allowing you to test your code in a controlled environment without relying on external factors that could slow things down or cause unexpected results.
Mocking sounds incredibly useful. Tell me more about how it works and how Jest makes it easy to do.
Well, Jest provides some really helpful tools for mocking. For instance, jest.fn allows you to create a mock function, essentially a placeholder that you can customize to behave however you need it to for your tests.
So if I had a function in my code that was responsible for playing a video, I could use jest.fn to create a mock version of that function without actually playing a video during my test.
Yeah, exactly. And there's another tool called jest.spyon that lets you keep tabs on how a specific function is being used without changing its actual implementation. It's like having a secret agent observing your code's behavior.
Wow, those are some powerful tools. Mocking definitely seems like a key concept to master when it comes to testing. But what about setting up the right conditions for your tests? It's like making sure your lab is clean and organized before you start an experiment, right?
You're absolutely right. Just gives you ways to set up and tear down your testing environment before and after each test to ensure you're working with a clean slate every time. Imagine you're testing a function that adds animals to an array. You want to make sure that each test starts with an empty array, right?
Yeah, that makes sense. You wouldn't want leftover animals from a previous test messing things up.
Precisely. And that's where Jest's before each function comes in. It runs a set of instructions before each test, ensuring you have a consistent starting point. There's actually a great example of this in one of the resources we're looking at today, the animals array test.
Oh, right.
So each test would start with an empty array, and then you could add animals to it as needed for that specific test.
Okay, that's really clever.
Mhm.
So besides before each, are there any other setup and teardown functions?
Yes. In addition to before each, Jest also provides before all, after each, and after all functions, giving you complete control over how you set up and tear down your testing environment.
Awesome. So it sounds like Jest really has everything you need to write comprehensive tests for your JavaScript code.
Absolutely. And the beauty of it is that it's designed to be intuitive and accessible, even for those who are new to testing.
This has been such a great overview of Jest. It's really exciting to see how powerful and yet easy to use it is. But before we wrap up this part of our deep dive, I'd love to hear a bit more about those setup and teardown functions. What are some real-world examples of when you might use each one?
Great question. Let's start with before all. This function is handy when you need to perform an action only once before all your tests run. For example, if you're testing code that interacts with a database, you might use before all to establish a connection to that database before any of your tests execute.
So it's like setting the stage for your entire testing suite.
Exactly. Now, before each, as we discussed earlier, is perfect for those actions you need to perform before each individual test. This could involve things like creating a fresh instance of an object, resetting a counter, or clearing a log file.
Okay, so each test starts with a completely fresh environment.
Precisely.
So then what about after each?
So after each runs after each individual test. This is useful for cleaning up any resources that were used during the test, like closing connections or deleting temporary files.
So it's kind of like tidying up the lab after each experiment.
You got it.
And finally, we have after all.
Which runs once after all your tests have finished executing. This is a good place to perform any final cleanup tasks, like disconnecting from a database or closing any open network connections.
So it's like making sure you turn off all the lights and lock the door when you leave the lab for the night.
Exactly.
Okay, cool. It sounds like these setup and teardown functions are essential for creating a controlled and predictable environment for your tests, which is so important for getting reliable results.
Absolutely. They provide a framework for ensuring consistency and isolation, which are key principles in effective testing.
Awesome. This has been such a valuable discussion about setting up the right environment for your tests. But how about mocking? I know we talked about it a little earlier,
Yeah.
but I'd love to go a little bit deeper. Can you tell me a little bit more about some of the specific scenarios where mocking can be really helpful?
Oh, yeah, sure. So let's say you're building an application that relies on a third-party weather API to display the current forecast. Now, You wouldn't want your test to depend on the actual weather API, right?
Right, because the weather changes all the time.
Right.
So your test could pass 1 minute and fail the next, even if your code is working perfectly fine.
You got it. Plus, relying on a live API could slow down your tests significantly, especially if there's network latency or the API is experiencing issues.
Yeah, that makes sense. So how would you use mocking to handle this situation?
Well, instead of calling the actual weather API in your tests, you could use jest.fn to create a mock version of that API call. You could then configure this mock function to return a specific weather response that you define within your test.
So it's like creating a little weather simulator within your tests, giving you complete control over the forecast.
Precisely. This way, your tests become much more reliable and predictable because they're no longer dependent on the whims of the real weather API.
That's so clever. It's like being able to control the weather for your code. What other scenarios would mocking be useful for?
Another common use case is testing functions that deal with time. For example, imagine you have a function that schedules a task to run after a certain delay.
Okay, I can see how that could get tricky to test because you'd have to actually wait for that delay to happen in real time,
Yeah.
which would really slow things down.
Exactly. But with mocking, you can manipulate time within your tests. Jest provides functions like just.useFakeTimers and just.advanceTimersByTime, which let you fast forward through time or even freeze it completely.
Whoa, that's amazing. It's like having a time machine for your code,
Yeah.
letting you test time-based functionality without actually having to wait for the clock to tick.
Exactly. This way, you can test scenarios that would normally take minutes or even hours to unfold in a matter of seconds.
Mocking is starting to sound like a superpower for developers. It gives you so much control over your testing environment.
It really does. It's like having a toolbox full of special gadgets that let you bend the rules of reality within your tests, making it much easier to isolate and verify specific pieces of code.
Now, I know we've talked a lot about mocking, but I'm curious about the situations where you wouldn't want to use it.
Sure.
Are there any potential downsides or things to watch out for?
That's a great question. Mocking is a powerful tool, but it's important to use it judiciously. One potential downside is that if you mock too much of your code, your tests might not accurately reflect how your application behaves in the real world.
Right, it's like building a house out of cardboard. It might look like the real thing in your tests, but it won't hold up in a storm.
Exactly. So it's important to strike a balance. You want to mock enough to isolate the specific parts of your code you're testing, but not so much that you lose sight of the bigger picture.
So it's a bit of an art form, knowing when and how much to mock.
It can be. But with practice and experience, you'll develop a good sense of when mocking is appropriate and when it's better to test against real dependencies.
That's great advice. It sounds like the key takeaway here is that mocking is a valuable tool, but it should be used thoughtfully and strategically.
Absolutely. It's all about finding the right balance between isolation and realism in your tests.
This deep dive into jest and testing has been so insightful. I feel like I'm starting to grasp the core concepts and see how powerful these techniques can be for building more reliable and robust software.
I'm glad to hear that. It's really satisfying to see how testing can transform the way we develop software, making us more confident and efficient in our work.
Absolutely. Now, before we move on to our final thoughts and takeaways, I'd love to hear if there are any specific best practices or tips you recommend for writing effective tests with Jest. What are some things that developers should keep in mind as they start incorporating testing into their workflows?
That's a great question. I think one of the most important principles is to focus on testing the behavior of your code rather than its implementation.
Okay, can you elaborate on that a bit? What's the difference between testing behavior and implementation?
Sure. Testing implementation means focusing on the specific details of how your code is written. For example, you might write tests that check if a particular function is called with certain arguments, or if a variable is assigned a specific value.
Okay, so it's like looking under the hood of your code and making sure all the gears are turning correctly.
Exactly. While testing behavior, on the other hand, is more about checking if your code produces the desired outcomes, regardless of the internal mechanics.
So it's like checking if the car can actually drive, regardless of how the engine works.
Precisely. And the reason why testing behavior is generally preferred is that it makes your tests more resilient to changes. If you refactor your code or change the underlying implementation, your tests will still pass, as long as the overall behavior remains the same.
Right, so you're not locking yourself in.
Exactly.
That makes a lot of sense. It's like future-proofing your test by focusing on the what rather than the how.
Exactly.
So any other tips for writing good tests?
Yeah, another tip I would recommend is to keep your tests concise and focused. Each test should ideally focus on verifying a single aspect of your code's functionality. This makes it easier to understand what each test is doing and to pinpoint the source of any failures.
So it's kind of like breaking down a complex problem into smaller, more manageable pieces, right?
Yeah, precisely.
Gotcha.
And along those same lines, it's helpful to give your tests descriptive names that clearly convey what they're testing. This makes your test suite much more readable and maintainable over time.
It's like labeling all your lab equipment so you know exactly what each one is for.
Exactly. Good organization and clarity are essential for effective testing.
This has been such a valuable discussion. I'm starting to feel a lot more confident about incorporating testing into my own projects. But before we wrap up, is there anything else you think our listeners should know about Jest or testing in general?
Um, One last thing I would emphasize is that testing is an ongoing process. It's not something you do just once and then forget about. As your code base evolves, so should your tests.
So it's like a living document that grows and adapts along with your code.
Exactly. It's an integral part of the software development lifecycle, helping you maintain the quality and reliability of your code over time.
That's a great point. It's like tending a garden. You wouldn't just plant some seeds and then walk away. You need to keep watering, weeding, and nurturing those plants if you want them to thrive.
Exactly. The same applies to testing. Your tests need to evolve along with your code base to ensure they remain effective and relevant.
This has been such an eye-opening deep dive into the world of testing with Jest. I feel like I've gained a whole new perspective on how to approach building software with more confidence and reliability.
I'm thrilled to hear that. It's truly rewarding to see how testing can empower developers to create better, more robust applications.
Absolutely. Now, as we wrap up this episode, I want to make sure our listeners have some key takeaways to walk away with. We've covered a lot of ground today. From the fundamentals of testing to the intricacies of mocking and the importance of setting up a proper testing environment.
You've summarized it perfectly.
So if there were just a few essential points you'd want our listeners to remember from this deep dive, what would they be?
Well, I think the most crucial takeaway is that testing is not just an optional step. It's an integral part of the software development process that can save you countless hours of debugging and rework down the line.
It's like investing in a good insurance policy for your code.
Exactly. And another key point is that Jest makes testing incredibly accessible and enjoyable. With its simple syntax, powerful features, and intuitive design, it removes many of the barriers that might have prevented developers from embracing testing in the past.
It's like having a friendly guide who walks you through the process step by step.
Precisely. And finally, I would emphasize that testing is an ongoing journey, not a destination. It's about continuously learning, experimenting, and refining your approach as your code base grows and evolves.
It's like a craft that you hone over time,
Yeah.
constantly seeking to improve your skills and techniques.
Exactly. And with Just by your side, that journey becomes much more rewarding and productive.
I couldn't agree more. This has been such an enlightening conversation. I want to thank you for sharing your expertise with our listeners today.
It's been my pleasure. Thank you for having me.
And to all our listeners out there, we encourage you to dive into the world of Jest and discover the power of testing firsthand. You'll find links to all the resources we discussed in the episode description.
Happy testing, everyone.
Until next time, happy coding.